So we're now going to transition into something that hopefully we can eradicate, and that doesn't imply too much for us all, but we all seem to have it, and that's inflammation. But the question is, how does chronic inflammation impact our health, and what can we do about it? Well, luckily we have a speaker and an expert here today who's going to share his knowledge on this. That's Jesper Eugen-Olsen. He has a PhD in medical science, and he's also a renowned researcher specializing in inflammatory biomarkers, particularly their role in chronic diseases and longevity. And I'm sure he's also going to talk about something called suPAR, which is part of this diagnostics. So please give it up for Jesper Eugen-Olsen.
Thank you very much. Welcome everybody. I'm going to talk about chronic inflammation, which is a really important thing we can measure now in blood. So I'm saying cracking the code to longevity, and I think there's something about that. I mean, if we can measure and master chronic inflammation, we can improve lifespan and health span. And it's actually only 30 years ago we became aware that there was this low-grade inflammation or chronic inflammation in the body that drove cardiovascular disease. This is from 2004, from the front page of Time magazine. And what happened then was we had this biomarker called C-reactive protein, or CRP. It's measurable. We know it. You go to the doctor, you feel ill, they do a CRP. If it's very high, then you have a bacterial infection, you get antibiotics. But somebody developed an HS-CRP assay, a highly sensitive CRP assay. And now we could suddenly measure CRP in everybody. And we found that if you had elevated CRP, or little bit elevated, thereby the term low-grade inflammation, then you had higher risk of such different diseases as diabetes, cardiovascular disease, and cancer. When I talk about chronic inflammation, what is it? For me, it's the language between our immune cells. So it's actually the communication that goes on in our immune system. Now, if we are exposed to viruses, bacteria, or pollutants and so on, our immune system will be activated and it will fight. And that's very good. Acute inflammation is really important to keep us well. We know it from a splint in the finger and so on. But chronic inflammation is something else. It's a systemic, ongoing immune activation and chronic inflammation. So we know now that a lot of drivers of chronic inflammation and also a lot of outcomes of chronic inflammation. For instance, xenobiotics, microplasts, smoking, pollutants in obesity. Our diet means a lot. We are learning more and more about diet. Physical activity, chronic viral infections. And all these, the more of the worst things we have, the more this drives this wheel for this wonderful paper from Furman in 2020 of these very different diseases. So it's, for me, it was really amazing when we first found this, that one mechanism is behind so different diseases. So CRP is really wonderful. If I measure your CRP today and tomorrow, however, there will be quite a lot of variation. On a population level, if I divided you into two halves here and measured your CRP and put all the high ones over here and all the low ones over here and waited 10 years, I would see a higher percentage over here, but also some over there. The problem is that CRP varies a lot, so it's good on a population level, but it's not very good on an individual level. So introducing suPAR, a biomarker I've been working with since the 1990s. If I measure that in you over the next 5 days, it will be quite stable. And so now I'm saying, I'm also the CSO of a company that I founded, which is on the Nasdaq Copenhagen. It's a listed company. We have a booth over there. Lots of conflicts of interest. But I worked 28 years in a hospital research department with many PhD students and making all this knowledge. So suPAR is quite a stable biomarker over time. Everybody has it. It's expressed by immune cells, but also something called senescent cells or zombie cells. It's a new type of cells that we haven't known for that many years, but it's cells that seem to not wanting to die. They do not want to undergo apoptosis, but they become toxic in our environment. And actually many things that we eat, flavonoids, blueberries and so on, it's drugs that kill senescent cells. I'm not going to talk about senescent cells today, but there was a really nice paper in Nature in 2020 where you train CAR T cells to kill senescent cells, and you actually use uPAR, or the cell-bound form of suPAR, because they are so highly expressed. But the more uPAR, suPAR you have, the more chronically activated immune system you have. So I've been working in a hospital for many years, and that's really why we know a lot of things about suPAR. We know when you come into an emergency department, many hospitals around the world measure the suPAR level, and this is 90-day mortality. This is from Hvidovre Hospital where I worked. And we see that if you had low suPAR, not many dies, but the higher the suPAR, if you come in at the ED with a suPAR above 10 nanograms, we see 50% mortality. So that's really where we've been using the suPAR biomarker in triaging in the ED. And basically, you use it to say if your suPAR is low, you have a good immune system. And we all know the feeling of having a good immune system. We are sick, but we get better. But if you have chronic activation, a suPAR above 6, it means that you have a high risk of negative outcome. But it also means, if you have a lot of suPAR, a lot of chronic inflammation, that you are not able to cope with the disease challenge. And for instance, during COVID-19, we had a lot of pressure on our ED, and this day made it closed down Denmark and the rest of the world. I went down and got a lot of blood from all the patients. I called all my friends in US and France and Germany and so on. We set up an international consortium on inflammation and COVID-19, having the idea that if you have a high level of inflammation, you could predict that you would get really bad of this. Because in the beginning, we were putting everybody in hospital if they had COVID, and it was exploding for us. So we set up a randomized, we found by checking all these biomarkers of inflammation that suPAR was definitely the strongest biomarker. And if you had a suPAR above 6, you had 50% risk of ending up, even though you were feeling well, of being intubated and mechanically ventilated. So we decided to, if you have a suPAR above 6, to close down your immune system by blocking your innate immune response, the IL-1 receptor. And we did that on a randomized trial on 37 hospitals, and we could save people from ending up. And it actually became the first biomarker-guided treatment approved by both the EMA and the FDA in COVID-19. But that's disease. That's hospitals, that's where we acquired a lot of the information we have on suPAR. But what about the general population? And I don't know if you heard Sven Brinkmann was just here discussing positive psychology, and it came up in something new. But actually, longevity is also something quite new in a way. I published this study in 2010 along with my colleagues, and there wasn't that much interest in it. In Denmark, we kind of seem to think, or in most of the world, at least at that time, that hospitals are treatment, and it's about you wait, you get sick, and then we give you medicine. But as in the new sundhedsreform, we also know now we have to take care of our health. If we are a growing number of elderly people, and we got to take care of our health span in particular and have a shorter span of disease before we die. And chronic inflammation is one thing that drives disease development. And what we saw that with, if you were in the highest, this is what's called the Glostrup investigation. We have these really wonderful cohort studies in Denmark because we have so good registers. But what we saw was that if you had elevated suPAR, you had higher risk of getting cancer, cardiovascular disease, and type 2 diabetes. And if we put people into, the Glostrup people into 4 groups, whether they had low or high suPAR in quartiles, we could see that if you had ended in the high suPAR group, 1 in 5 people had died at the age of 60, but people who had low chronic inflammation, they had 1 in 5 died at the age of 75. That's 15 years of difference, right? And since then, we've done a lot of studies, and I don't have the time to go into all of them, but this, I think, is really interesting. This is also a Danish investigation of more than 6,900 people, where we looked at diets and follow-up on disease and mortality. And what we saw was, according to the diet quality score of number 9, actually our suPAR is following also our diet. There's a linear association between what you eat and your level of chronic inflammation. We also know that social isolation, people who feel lonely, which also is a driver of disease, we can measure on suPAR, not CRP and IL-6, but because suPAR is more sensitive and better, that even people who live alone or feel lonely have chronic inflammation. Stressful life events, and you get bankrupt, you get divorced, and all these kind of the more bad things in your life also builds up in chronic inflammation. So, and all these papers ended up in, we wrote this review. Line J. Hartmann Rasmussen is a fantastic colleague and an amazing suPAR researcher. And we put in this paper forward 10 arguments for why we have now this biomarker of measuring chronic inflammation. Because everybody has talked about chronic inflammation, and we haven't really been able to measure it. And we have all these things showing associations with chronic inflammation. Now, I want to turn your attention to the Dunedin study, because for me, that's the most important population study in the world. Because when I talk about Danish cohorts, Inter 99, Glostrup-undersøgelsen, Østerbro-undersøgelsen, it's something we get in our e-box. Do you want to participate in this clinical trial? We want to follow you over time. And I guess you who sit here, yes, you would like to participate in a clinical trial, but maybe the guy sitting down on the bench drinking beers all day is not going to check his e-box. So we have what we call a bias in population studies. How can we do a study that determines what makes people happy, rich, poor, professors or junkies, criminals? And that was actually what the Dunedin study was set up to do. And what they did was including pregnant women in the 70s, 72, 73. And these 1,037 individuals who were born 1972, 72 are the most followed people in the world. Every 7 years, if you were born in Dunedin, a city in New Zealand, in that year, you would be flown in to New Zealand every 7 years and undergo 14 days of investigations, questionnaires, economics, full genomics, MR scanning, psychological tests, your sexual preferences. We know everything about you. And what's really amazing is that there's a retention rate of 95% of those who were born into the cohort. So people stayed in this cohort. And we follow them through life. Here is just one of the volunteers, one of the persons who, they are anonymous, but she put out on the internet that she was in this study. And we, at 8 years old, we know her, 11 years old, 16 years old. And we did a study because I was also very interested in how early does chronic inflammation come? Is it something we can measure from birth? Is it something that comes to life? Is it the end of our life? And what Line, that I mentioned before, we were doing was to investigate in the Dunedin cohort and the ERIS cohort of London, people at 18 years of age, and we looked at adverse events in childhood. That could be abuse, sexual abuse, alcoholic parents, mobbing, so on. All these kind of bad things. And what we saw that the more of adverse events you had in your childhood, already at year 18, we could see association with elevated chronic inflammation, elevated suPAR. And we followed them on, and now I'll show you some data from when they were all 45 years old. Right now they are 52, and we are doing the 52-year investigation. But at 45, you know it also, those of you who are at least my age, and go to a 40-year anniversary for high school. Some people look quite young. Some people just look older. Some people age faster than other people. And so all these people are 45-year-old, but we used a computer to generate kind of the 10 oldest and the 10 youngest and the 10 in the middle of these 45-year-olds. And we call that facial age. Facial age is also a biomarker of aging. And we were very interested in finding out whether suPAR is associated with the pace of aging. We know it's associated with development of diseases and so on, but what about pace of aging? And what we found was that when we took these 1,000 individuals and divided them into quintiles, like 200 persons in every room, according to their suPAR level, we could see that if you had a suPAR in the highest quintile, you age around 1.2 year per year. So if you have a lot of chronic inflammation, you age faster, but you also look older. So people in the highest quintile look much older, and people who have a low suPAR, they age slower, they look younger. And when we look at their brain in an MR scanner, I was talking to this professor at Duke, and he was really amazed about suPAR because it was the first time there was a biomarker in blood actually correlating to the age of the brain, as they determined using the gray and white matter in MR scanning. So the higher the suPAR, the faster you age. So that's not very nice, right? Childhood adverse events and all these kind of things that add up, and can we not do anything about it? So we asked, I had Thomas Haupt, a doctor who did his PhD on suPAR in the general population, and he took the Inter-99 intervention study where we looked at people at baseline and after 5 years and tried to change. It was actually a study planned by the Danish government. Can we in Denmark prevent cardiovascular diseases by offering people who smoke free nicotine substitution, free fitness cards, dietary advice? Could we actually prevent diseases? And it was published by Glostrup in British Medical Journal that they couldn't. There was no difference. However, when we looked at people with high suPAR, the highest 25% in the two arms, it actually does matter, and we could prevent disease, but you need to have a risk before an intervention works. But okay, that was another study. In this study, we looked at people here, for instance, you have suPAR, and these are people that exercise a lot. And baseline and after 5 years. And these are people who do not exercise and after 5 years, and these are in between, right? So really, exercise really matters for your level of chronic inflammation. It's actually as strong almost as smoking. Smoking is probably, number one in creating chronic inflammation in your body. So if you smoke, we did a study on more than 1,000 individual smokers for 14 years, and actually smoking and high suPAR is associated with development of lung cancer. So if you smoke, you shouldn't do it at least with high suPAR. And what we also saw that if you stop smoking, you decrease in your suPAR level. And what we did out here, we took the last suPAR level, we looked at mortality over the next years, and we saw that if you had lowered your suPAR, you also lowered your risk of mortality. So suPAR is kind of an early warning. If you have elevated chronic inflammation, you can do something about it. Change lifestyle, exercise, eat more healthy, and so on. And just to show that you can actually do something, this is a randomized controlled study where we randomized smokers to continue smoking, these are never smokers, or quit smoking and then randomized to nicotine substitution or nicotine placebo patches. And in 4 weeks, we see a significant decrease in chronic inflammation and suPAR in the body, right? So now smoking is very potent. If you start to eat more healthy, I would say you need to go into a longer time before you will see the effect on this biomarker. But this has really opened our eyes for studying other things that are interested in regard to longevity. So another thing we've been working a lot on is suPAR in itself bad for our body? If we look at CRP, for instance, you can be born with genetic composition that gives you a lot of CRP, but it doesn't drive cardiovascular disease. So elevated low-grade inflammation measured by CRP is associated with something, but it's not causing it. But if you have a high suPAR, we did a study, we measured suPAR in 26,000 individuals, and then we did a full GWAS. Then we found a mutation associated, 10% has a mutation associated with slightly higher suPAR. And we went to the UK Biobank, 500 or 350,000 individuals, and the 35,000 who are born with elevated suPAR were more likely to develop diseases. And when we overexpress suPAR in a mouse, it also develops arteriosclerotic diseases. So what we conclude is it's very good to have a low suPAR, but in itself, actually, suPAR is also causal of kidney diseases. And we had a nice feature in Science calling suPAR omen in the blood. It predicts diseases, but can it cause them? And that paper came after the Science publication. So it's always good to have a low suPAR. So I told you that the higher the suPAR, the faster you age. The more chronic inflammation. If you have chronic inflammation, do something about it. But what is a normal suPAR level? If you measure your suPAR level, is that high or low? And for that, we have developed a biological clock based on 9,300 Danish blood donors. Blood donors in Denmark are pretty healthy. They don't have diseases, they're not on medication, but they can live as they want. And so, but for that, we know what a median suPAR would be. And if you have suPAR above the median of a blood donor, we know from the Dunedin study you are aging faster. So we combine the knowledge of actually women have a little bit higher suPAR than men. But until the age around 75, then the men goes past the women. But we can use this knowledge to create a biological clock. So this, for instance, is a woman age 50 with a suPAR of 2.1. That's below the median, so she becomes younger and age only 0.93 year per year. And if a woman, the same woman, would have a higher suPAR, we would. And this is what's offered by more and more longevity clinics, this kind of biological clock. We have some success on that, getting like a new clinic every week right now, because it's a simple measurement. Yes, it's blood, but it gives you this is mostly developed to be able to understand for a client what does my suPAR. People understand biological age better than 2.17 nanogram per mil, right? So we know all these things. I didn't go into long education and so on, but actually I live in Hellerup. And if you live in Hellerup, you have lower suPAR than if you live in Brøndby. And the longer education you have, there's a big American paper came out last year, the lower suPAR you have. And all that is quite, exercise, and that will slower your rate of aging. And right now we are in this field. I think with this biomarker, we have the opportunity now to maybe test whether rapamycin or fisetin or many other interventions, hyperbaric oxygen chambers, what do I know, whether it has an effect on the chronic inflammation and the pace of aging. And we are, right now, Hvidovre Hospital is doing a very big randomized control study in people who are suffering from accelerated aging, meaning they have a suPAR above 5 to fisetin, which is this flavonoid found in strawberries and senescent molecules killing senescent cells. And we are also planning to do a rapamycin trial. I don't know if you heard about rapamycin, but it's something of one of the most hot drugs right now in the field of longevity. It makes every organism live 15 to 25% longer. Banana flies and worms and mice and dogs, and it's being tested in humans right now. And the whole purpose is really to have maybe a longer lifespan, but definitely a longer health span. Go as long as we can without developing all these diseases. So that's about it. What I would like to say, overall, suPAR is a good indicator of your overall health status and risk of disease, and if what you're doing is working. And I have room for a question or two. Yeah. I don't know if there's a microphone. Do you have a microphone?
Thank you so much for the talk. So I was wondering, these types of interventions you talked about, sleep, eating, workouts and stuff. Do you have any idea of the relative effect on suPAR? So what's basically the most efficient way to start lowering this? Do you understand?
I mean, we do have these data from all these investigations of exercise and so on, right? I don't know if zone 2 training or muscle training, but I think, muscle training is really important because your muscle produces these myokines when you exercise, and they are anti-inflammatory in your body. But for your cardio, that's also very important. And I think, it's in only maybe we are becoming more and more aware that if we want to have a long, good life, we have to exercise. It goes for men and women. And muscle training, I think, is very important, but we haven't done any where we divide it into those two. What's best in training, we haven't done any of those experiments. I think a combo, but I don't have data for it. Yes? Yeah, I guess so. And actually, we have a booth right behind you. You have Thomas and Kern standing now there. They are in the company Virogate that I founded 20 years ago. So you can hear about the test down there. And
Okay.
I don't have a...
I was just wondering, is this associated with any other inflammatory markers that you can measure at the same time to really look at, okay, is this essential oils driving, or which other markers can you look at to kind of get a more full picture?
The inflammatory markers.
Inflammatory
Well,
markers.
in all these studies, we typically have CRP and IL-6 as part of it. I think IL-6 is better than CRP. There are many good biomarkers. The problem is the way we have defined chronic inflammation has been based on acute inflammatory biomarkers. TNF alpha, IL-6, IL-1 beta. Now these biomarkers in your body are associated with when you get inflammation. But they're very label. TNF, for instance, is supposed to work where it's produced, and then it will break down very quickly. Because if you have circulating TNF, you will have an ongoing. And as soon as you take a blood sample, you actually change. It's very hard to measure. Maybe suPAR is so good because it's a very stable protein. Maybe it could be better to measure other biomarkers, but suPAR is very stable. And that makes it very easy to measure. But we always, in all our studies, we have tried to find good biomarkers for chronic inflammation. And we have tested a big number of them. So. You have one more?
All right. So you mentioned that perhaps rapamycin could be lowering suPAR. So I take it that other nutrient sensing pathways like mTOR or AMP kinase could be nutrient sensing pathways that you also expect could lower this. Is there any evidence on this?
Yes. We have some wonderful longevity drugs, and it's interesting, actually, longevity drugs we have right now that are most promising come from deceased individuals. If we look right now, the most promising are SGLT2 inhibitors, GLP-1 analogs, we know it like Wegovy. If we take that, for instance, which is supposed to just make you lose weight, it turns out that it also prevents onset of Alzheimer's. It has protective effect on your kidneys. It reduces cardiovascular disease by 30%, something like that. It's quite amazing. Metformin, a lot of discussion going on, pre-diabetes medicine. So we learned a lot from these drugs, and they are crossing from deceased individual into their health span. There are many biohackers in this room here today, right? And people experiment with a lot of things. There's a lot of vitamins. There's a lot of good things and things we can take. And And some of these most promising rapamycin you mentioned, I talked a little bit. It came from, it was found in the 60s by Canadian researchers who went to the Easter Islands. They had the Rapa Nui people there. And these Rapa Nui didn't really develop any of the chronic diseases we know in the Western world. And they went into the cave to get the water. Is there something in the water? And they took soil from the ground and they took it back in the lab. And in the 70s, they found this bacteria that produced rapamycin as an anti-fungicide. So it's a bacteria producing rapamycin to kill fungi. It's exactly the opposite of antibiotics. That's fungi killing bacteria, right? And they took it back home and they found that if you give a lot of rapamycin to a person, it suppresses their immune system. And that led to a 1996 FDA approval as a drug. But then we discovered mTOR1 and mTOR2, the two receptors you're asking about, right? And if you give a lot of rapamycin, you activate mTOR2 and you suppress the immune system. But some studies in elderly people giving low amounts of rapamycin and vaccine improves their immune response. So it seems to have a dual phase. And so rapamycin maybe 4 to 6 milligrams once per week, rather than high amounts every day, seems to have the opposite effect. And there's a lot of, if you can go to the internet, there's a lot of people eat. I would like to do an experiment, 4 months of rapamycin or placebo. Does it lower your chronic inflammation and pace of aging? Hit me. I'll eat it. All right, I think I used all my time, so thank you very much for attending.